Now imagine for a second that you're creating a video compression application, right? And the flow is that a user uploads a video, that video is compressed, the video is stored, and then it is returned to the user, right? And users come in just to do that. Now, when a user uploads a video and that video is being uploaded, should the application halt and wait for the upload to be complete before going up to the next step? And the user just keeps waiting. That's not a very good user experience. It tends to make your app seem slow. So a good way to handle this is to have this application process the data asynchronously. That is, after the application is uploaded, the user can go on to do other things on the application while that is happening, right? And you can do this using a message broker. How a message broker works is that you perform an action, and that action is put into a queue instead of being handled asynchronously. So it's put into a queue, and the back end of the application collects data from the queue, processes it, and stores it, collects the next one and processes it. And this happens asynchronously, not synchronously, immediately. One application broker that you can manage easily is RabbitMQ. So RabbitMQ helps you to decouple systems in that the request can now be processed asynchronously by using a queue. And then an immediate question that can come into your mind is, what's the difference between Kafka and this RabbitMQ, right? Well, Kafka is an event streaming platform, which is different from RabbitMQ, which is a message broking platform. So while Kafka handles things like event streaming, log replays, RabbitMQ does things like message routing. So you want to say that, okay, this message coming from here should be routed to this particular service. You can use RabbitMQ for something like that. If you want to implement task queuing, right, in an event bus system, you can have RabbitMQ perform that kind of job. Not necessarily something as intensive as event streaming or data streaming. You can use RabbitMQ for that. So you have the producers which produce or creates the message and sends the message into the queue. The queue is what holds the data before they are sent to the application that will process that data, which is called the consumer. So you have the producer gets data, sends it into the queue holds the data while the consumer is processing all that data. And when it's done, the queue sends that data to the consumer. And what determines where the destination of that data is being sent is the exchanges. So exchanges determine where a message is going to be sent to. Finally, you have the routing key, which helps to direct the messages to the exchanges correctly. RabbitMQ works with the AMPQ protocol, and that's how it's able to do the routing in data with that protocol. And you can easily set this up again using a Helm chart on your Kubernetes cluster, or you can use a Bitnami chart and deploy this to your Kubernetes cluster and handle your message broken and asynchronous events efficiently. I hope that helps. All right, I'll see you next time.